Okay, so hi everyone, I'm Merron. Today I'm going to be talking a little bit about how our prior spatial knowledge can impact learning differently in children and young adults. So when we're learning something new, our past related experiences can help ground that new knowledge in what's been called proactive facilitation, and this occurs in a variety of different tasks. So if you think of yourself encountering this bedroom for the first time, you might note the location of the teddy bear, the airplane, and the basket of dinosaurs. And then when you encounter it for a second time, you now note the location of this toy car and the video game controller. And so as an adult, your past experience with this room might actually help you encode the locations of those new objects, such that you remember them better than if you encountered them in a completely novel spatial context. In fact, this has been demonstrated broadly in rodents as well as adult humans, that they have this facilitated learning when they have prior spatial knowledge. Something that might be accounting for this behavioral phenomenon is that adults may be able to retrieve their related memories during new learning, which could allow them to ground their new associations that they're forming in their prior knowledge. So you could integrate these memories and, for example, note that the pink car is 2 drawers above where you saw the airplane. However, the brain regions that are thought to support this behavioral phenomenon of facilitation are late to develop. So children might not be influenced by their prior spatial knowledge in the same way as adults. So if a child had the same experience where they first encountered the room with the 3 objects and then later with these 2 new objects, they might actually not show that benefit of prior experience in the spatial map. And prior work with associative learning has suggested, in fact, that children may keep their related memories separate. So instead of integrating these 2 experiences, they might keep them separate. And thus not benefit from integrating those 2 together. And this recent neuroimaging work suggests that this might be because they don't do that reactivation of prior related memories, and so they don't necessarily integrate those related memories together. So in our project, we are interested in whether children showed this facilitation effect that's been seen in adults in spatial learning. So we had children 4 to 11 years old, as well as adults, complete a series of spatial learning tasks through this virtual iPad card game. So in this game, we had this 2-dimensional layout of face-down cards, each of which had a unique object on the other side. And subjects were prompted with this target object, so the milk here, which they had to search for among the different cards of the layout. And so if we went through an example together, you might choose to look under this card and see the grapes, and then this card and you see the guitar, and then finally this 3rd card and you finally find the milk. And after you located the target, the new target object would appear. And so in this manner, you would locate every single object in the layout. And we had subjects do this repeatedly. So they would repeatedly find every single object until they reached our criterion, which we defined as locating every object with a single touch for 2 consecutive rounds of learning. So this is how they learned these layouts. And after they had completed this initial learning, we then added new locations to see if adults and children were benefited by their previous experience with this spatial map. Oh, and these are some examples of the cards that they saw. So they were all child-friendly objects. So as I said before, we had this initial learning phase where they first encountered and learned the maps to criterion. And then we had this new learning phase where we incorporated new locations amongst the old locations. So if I actually drag over this map, you can see that the grayed out cards in this new learning phase correspond to the previously learned locations. But in this phase, they weren't able to flip those over, so they were only learning these new locations. So we were interested in whether they could learn these new locations faster, since they were in a previously learned spatial map, and learning proceeded in the exact same way as the initial learning phase, where they discovered the location of every object. So in order to look at our differences, we wanted to see whether this was different if you had this prior spatial knowledge. So this was called our overlapping condition, where we had our first set of A1 objects and then our second set of objects. We also had control conditions for each phase. So in the initial learning phase, they also learned this pink map. So it was a completely novel, completely different spatial context, different locations, different objects. And then we also had a corresponding new learning non-overlapping phase. So you can see these bottom two layouts aren't related at all. So in this condition, there isn't any prior knowledge that could potentially facilitate learning in that non-overlapping condition. In this condition, we also visually matched it. So they had these grayed out cards in that blue world, but the grayed out cards in this case didn't correspond to any prior learning. So we compared the rate at which they learned the locations in that new learning phase to see if they learned faster on the overlapping. And this is just the overview of how they learned. So it was within subjects. Every subject learned all 4 layouts. And our predictions are here. So for the adults, we expected a pattern consistent with facilitation, as has been shown previously, where adults would show faster learning on those overlapping layouts when the new locations were added to an existing map, as compared to the control condition. Whereas children, we expected to not be as affected by their previous experience with the layout. And so we expected no difference between the 2 conditions. Getting to what we were actually measuring when we're talking about learning rate. So what we looked at was we looked at the decrease in errors that they made over learning. So here I'm going to plot an example subject's data on the initial learning phase, so not the new learning phase. So what we are looking at here is the proportion of cards that they touched on every trial over different repetitions. So as I went through before on the milk trial, you might touch 3 different cards before locating the milk successfully. So that would count as 3 out of 12 cards touched. The reason we used a proportion is because we had children learn fewer cards to equate the learning performance so that we wouldn't have any main effects of age here. So if we look at this subject's performance, you can see that the proportion of cards that they touch per trial decreases over learning, which is as you might expect. As they learn the location of every object, you make fewer errors until you reach perfect performance, which is 1 touch per trial, which was our learning criterion to move on to the next one. And we fit this performance with an exponential function, letting this beta value vary in the corner there. And so this is what this subject's learning curves looks like for the separate 2 layouts, as well as their beta values. And so you can see for this subject, their performance is quite similar across conditions. This is what we would expect for the initial learning phase, because there's no difference between conditions at this point. So this was actually true of all of our subjects when we fit their performance with these exponential functions and compared. There were no differences across age groups, so we successfully equated learning rates, and there was no difference across conditions. And then for our primary question, we fit the same exponential function to their learning rate in the new learning phase. So this is looking at on the y-axis here, this is learning rate by that beta value. So a higher beta value corresponds to a steeper decline in the learning rate. So faster learning is with a higher beta value. So if they're higher up here, that means they learned the layout faster. So we actually found our expected interaction effect, where there's an interaction between age group and condition, but the direction of the effect was in the opposite one that we expected. So for our adults, we actually saw marginally slower learning on the overlapping layout. So that means that maybe they actually experienced some interference from their prior experience with that spatial map. And children showed a numerical effect in the opposite direction, but this wasn't significant. So they showed maybe slightly faster learning on the overlapping layout, again, in contrast with our predictions, but it wasn't significant. However, comparing across the age groups, we did see that adults were significantly slower than children on that overlapping layout. So as I was saying, contrary to our predictions, we might see some amount of interference for the adults, given their prior experience with a spatial layout in this task. And next, we also wanted to look at developmental differences within the child sample, since it was quite a broad age range from 4 to 11. And a lot of that prior work that I mentioned before, looking at associative memory and how children might keep those related memories separate, has looked at the older side of that age range. So we medium split our child group into those 4 to 7 and those 8 to 11 years old. And we again looked at their learning rates across conditions. And what we see is a marginally significant difference between the younger and older children, in particular on this overlapping layout. So it seems that children were slightly faster to learn on the overlapping layout than the older children. And this is quite interesting. Actually, the older children sort of are demonstrating what we expected to see with the children overall. So there's very little difference across conditions, which could mean that they're not really being impacted by their prior experience with that spatial map. But the younger children might be experiencing some amount of facilitation. So in summary, for our adults, we saw that prior experience with a spatial map may have actually interfered with new learning. And this is in contrast to pretty much all of the previous work that have used similar paradigms. So why might this be the case? Well, a key difference was that most prior work uses multiple days of learning on this initial layout before new locations would be added. So in our case, we actually had adults learn these initial locations on the same day and within the same session as these new ones. And so it might indicate a couple of things. So our differences from prior work could indicate that there's an important effect of consolidation. So it might be that you need to consolidate those initial memories before they can actually serve as a viable basis for new learning. It could also indicate the importance of having a super strong initial memory before you build on that with new locations. So both of these things might be at play here in the difference. And then one final thing that I'll mention here is that we looked at learning rate as I went over, but a lot of the prior work has looked instead at later memory benefits. So we looked at how quickly there was a decline in the number of errors that they made. But for example, the rodent studies have looked at one-shot learning, where they give rodents one experience with the new locations, and then they later look at their memory for those locations. And so these might not be in direct contrast, and we need follow-up work to determine whether it's possible that even though learning was slow, you still see later protection from forgetting, let's say, for those overlapping locations. And then as for our developmental results, well, we do see that children seem to be impacted differently by their prior recent spatial memories than adults. In the older child sample, as I mentioned before, it might be consistent with that idea that they're less impacted by their related memories during new learning. And in this younger children, we sort of have this open question now of, is this actually an effect? So we need to follow up with a larger sample. And also, if this is an effect, why are we seeing it? So are they benefited by their familiarity with the spatial context, or is there actually some benefit to them of recalling their previous spatial map? And with that, I'd like to thank all of you for listening, and my co-authors, and Dr. Mike Schlichting, and all of the Budding Minds Lab.